Hi, in this presentation you are going to learn how to subtract fractions. I've written down a rule for you. You need to check if denominators are same, just subtract numerators. Otherwise, first make denominators equal. Right? Now, what do you mean by a denominator? Denominator is the bottom part of a fraction. Basically, your fraction is out of those many parts. For example, if I've got this, I've just tried to make a pizza. I've split it up in 8 parts. So in this case, my denominator is going to be 8. I've got a whole pizza. So if I write down here that I've got whole pizza, which is 1, and I'm trying to, let's say James has eaten 3 slices of this pizza. So he has eaten what fraction of this pizza? He has eaten 3/8. So out of the whole he has eaten 3/8. Now I need to think that how can I change this whole into a fraction. Now whole can be, one whole is actually the whole item, so that means but this whole is been split up into 8 parts. So how many parts are there? So in all together I've got 8 parts out of 8. Take away or subtracting 3/8 which James has eaten. So now I can see that denominators are equal, so they are same. 8 take away, so I can see that 8 here, 8 there. So denominators are same. So what I need to do now is the rule if denominators are the same, just subtract numerators. So we need to subtract the numerator. Numerator is the top part. Okay, so 8 take away 3. That leaves me with 8 take away 3 is 5. So I've got 5 out of 8 parts left now. So that is the answer to that. Now fairly straightforward. I can give you a question to practice. If you try this question, 13 over 17 subtract 5 over 17. Okay, once again denominators are same, so what would be your answer? Yeah, you're right. It's 13 take away 5. 13 take away 5 is going to be 8 over 17. So if I had 17 part, if I had 13 parts out of 17, and I have taken away 5 out of 17, I'm left with 8 over 17. Now fairly straightforward. Now what do we do with the second case? Otherwise, first make denominators equal. What if your denominators are not same? If they are not the same, what do you do? I will put down an example for you. Subtracting mixed number. We're going to, if I have got a fraction, let's say 3/5, and I'm subtracting 1/4. Now clearly you can see that denominators are different, right? Now we talked about this in one of the lessons before when we were trying to add 2 fractions up, that you should try to make these denominators equal first, right? Now there are different strategies to make these denominators equal. We talked about getting the lowest common multiple. The lowest common multiple are 4 and 5. Multiples are the numbers from times table. So if I try to write down 5's times table, which is going to be 5, 10, 15, 20, 25, 30, 35, 40. You can carry on with that. And now if I try to write down 4's timetable, 4, 8, 12, I've got 16, 20, 24. 24 falls in 28 and so on. I can see that 20 is the common multiple, or the first common multiple. Now somehow we got to try getting 20 here, because that can be the common denominator for 5 and 4. Okay, you can, if you go further ahead, you can get 40, but that means you're multiplying, or you're trying to get bigger numbers. Okay, now if I need to get 20 here, what do I need to do? I need to times 5 by 4. Now we've got a rule, and the rule is if you multiply that number by 4, you got to do the same at the top, because your fraction has to be an equal fraction. Otherwise you will be changing the size of the fraction, right? So what you do is, you can see that 3 times 4 and 5 times 4, because you're making it 4 times bigger, so your actual fraction is still 3/5. Now you do the same thing here. How can you change this 4 to 20? So you really need to times 4 by 5, don't you? Okay, and you do the same thing at the top. Okay, once again we need to make equal fractions. Okay, so that fraction, now going back into that will become 12 over what do we get? It's 12 over 20, am I right? Take away, subtract 1 times 5. 1 times 5 is 5 over 20. So now you can see that my denominators are equal. Okay, and that's what we're trying to achieve. Okay, if denominators are the same, you can actually subtract numerators now. So what is 12 take 5? 12 take 5 is 7 over 20. Right, now we can show this. We can show this in a diagram as well. If I draw, I probably can show this in a picture. I need to draw 3/5 in a diagram. So I've got this rectangle, because when I look at fifths and quarters, I probably will be getting a rectangle. Okay, so what I do is I try to split this side into 5 parts. Right, so this is going to form, now I've got 5 parts here. Somehow I need to shade 3 of them, but I will leave that for later. So I will do, let me split this side, this side of the rectangle into 4s. Okay, so if I'm going to I need to make 4 parts on this side. Now so I've got 4 rows, 5 columns. Okay, so in total I've got 5 times 4, 20 rectangular parts. Right, now I need to subtract a quarter from 3/5. So I need to first shade 3 columns out of 5 columns. So which means that all these parts, so 3 columns will be shaded. Now you can see that I have shaded 3/5 now, so I can write down here so that this is 3/5, and on this side I got to have a quarter. Now I need to take away 1/4. Now I've got 4 rows here. Now each row has got how many rectangles? I've got 1, 2, 3, 4, 5 rectangles. So that means I need to unshade. I need to take away 5 parts out of these 12 parts which have been shaded. Okay, because my row, each row has got 5 parts. Now problem is, because when I was shading columns, I did not shade a row as a whole, so I need to take 5 parts away from these shaded. Okay, so what I do then, I will try to take away, I will try to so if I unshade that 2, 3, 4, 5. So mathematically what I have done here is I have unshaded, I have taken away 5 parts out of there, so which is equivalent to shading 5 of these, one of the rows, right? So how many parts are left then? So how many parts are shaded now? So you can see that I have got 1, 2, 3, 4, 5, 6, 7 parts shaded out of 20. Now this is similar to what we got here, 7 out of 20, right? Now as we always do, I always give you a question to practice, right? I would like you to practice this question for me, please. It's 3 quarters. You need to subtract a third from it. Right, you can pause this video now, and once you are finished you can check answer. Okay, we can see that denominators are again not same. Okay, if we look at the common denominator for 3 and 4, I can put down 4's timetable and 3's timetable. Okay, from looking at these two times tables, you probably would have spotted that the common denominator is your common denominator is going to be 12. Okay, how do you achieve 12 here? So to achieve 12 here, you need to times that by 3, don't you? Okay, so you times that by 3 as well. Okay, and to get 12 here, you need to times that by 4. Okay, and times the top number by 4 as well. Right, so that gives me 9 out of 12. So if I do 9 over 12 and I try to subtract 4 over 12, so if I do 4 over 12, so what's my answer then? 9 take away 4 is 5 over 12. Is that what you got? Right, okay, thank you, thanks for watching.